Hello and welcome to the Daily Space for today, October 16th, 2018. I am your host, Dr. Pamela Gay, and I am back from Australia and still working to get everything working correctly, including my brain. So let me see what I can do to fix the chat. So I've been gone. I've been down under. I would like to share that Australia is a fabulous nation that is filled with wombats and terrible Wi-Fi. So thank you all for your patience, and thank you so much to Andreas Plazas and Matt Richardson for filling in for me over and over while I was down under. Now, it turns out that while I was gone, all the news that could possibly happen happened. I'm going to bring you what I can and try and get us all up to date on the goings-on around this universe. So, in today's first story, I have a tale of supernovae. There was a wonderful case of make a prediction, search the surveys, and find those observations that match your results. This is kind of one of those magical things that modern data archives allow us to do. In research coming out of the National Astronomical Observatory of Japan in their theoretical astronomy division, there were predictions that a neutron-star binary system would have a very particular looking supernova when that second neutron star is formed. In these systems, you can end up with the stars taking turns stripping mass off of one another until they get to that point that a supernova occurs. Here we had a system where one neutron star had already been formed, various stripping of the atmosphere of the other star had taken place, and when it went supernova, it looked somewhat different from what we would normally see. Now, this was predicted, exactly how it should appear was predicted, and what scientists did was a research team, including Takashi Moriya, proposed this hypothesis formula for neutron stars. And then, given these predictions, a team led by Kashala D. from the California Institute of Technology went searching through the Palomar Transit Factory archives, looking to see if a supernova matching these predictions could be found. So, the PhD student from Caltech found it. So here we go. This is a picture of the system that was found. This is supernova IPTF 14 GQR. Again, astronomers should not be allowed to name things. So this completely matched Takashi Moriya's predictions, and now we have a literal picture of a neutron binary system in the process of forming. Now, one of the amazing things about astronomy is, while a human life is generally too short to observe all the stages of evolution of any given object, let's face it, our 80 to 100 years is nothing compared to the millions to billions of years of a single star's evolution. But because the sky is vast and we can observe a myriad of different objects, we have the opportunity to catch these neutron star binaries across a myriad of different stages of their evolution. And here we're sort of taking the Benjamin Button approach of watching them evolve backwards. As you may remember, back in August 2017, we were able as a community to catch, using multi-messenger astronomy, a neutron star binary system merging and releasing gravitational waves. These observations were made such that we observed the gamma rays, we observed the gravitational waves, we observed the particle physics results of this binary star collision. Well, having confirmed these systems exist, having confirmed this is where the majority of gold in our lives comes from, it's now cool to know this is how those neutron star systems form, and our theory matched reality. Anyways, this is just an exciting piece of science that I love because theory and survey data were able to be combined to prove this theory worked. It's kind of cool. Now, in a different case of trying to figure out what's going on with our observations, we have a story of a planet with giant rings. Robin Mental, a master's student at Leiden University, has been trying to understand what is going on with the system J1407. This is a system that is presumed to have a planet with massive rings. This particular set of predictions is made based on observations of a really weird transit that was observed. Now, the issue is, if you observe one transit, you should observe others. So, where are those others? 2 years ago, Mental, who is still a bachelor's student, went through 490 photographic plates, looking to see what could be found. And in this particular system, and sorry, I have something in my throat. I need to take a drink. Went through all of these glass plates of this system. And in looking through the glass plates, they were trying to figure out when might there have been a past eclipse, a past transit of this system. None were found. I'm so sorry. Okay. Let's see if I can get through this without coughing anymore. I don't know how radio people do this and why we don't see network anchors coughing more. In looking at this system, they were trying to figure out, is there going to be another transit such as been previously observed? By going through all of the glass plates, they were able to figure out, here are the times when we observed, or in this case, didn't observe transits. Here are the times the star was observed, and any past eclipses that may have taken place had to occur in the gaps of the observations. Well, since no transits were observed, no eclipses were observed, this means that they were able to limit when such things could have happened in the gaps in the observational period. It is now felt that there is going to be another transit, presumably in 2021 or 2024. So this is one of those cases of, it's not an extraordinary observation. It's an extraordinary lack of observation. Something was observed, went through the records, looked to see if we could use past observations to figure out an orbital period. Didn't see any past observations, and the gaps in the observations allow us to figure out what this object's period must be. It's kind of cool because it's a null result. We don't get to talk about the null results and how they lead to new understandings very often. Now, moving on and continuing our tales of planetary astronomy. In this case, we have results coming out of the University of Cambridge. Observations have turned up using the ALMA Atacama Large Millimeter Array, observations of the star Ca Tau. So this is a variable star in the Taurus system. This is a star that's about 500 light years away. Observations of this system made in the millimeter have turned up a disk of material around an extraordinarily young star. As they look at this young star, they've been able to turn up a whole suite of hot Jupiters. Now, while we've found plenty of hot Jupiters before, we haven't found this many in one system before. These planets are getting observed by the gaps that they create in the disk of material around this young star. Looking at the gaps and looking at the size of the gaps and looking at how the disk is warped, we've been able to come up with a variety of different masses And it turns out that 2 of these planets appear to have masses 10 times that of Jupiter. This is not what we expected. And so the question now is, how do we form a solar system like this using current planetary formation models? And the answer is we don't. We need new models. Planetary formation is one of these things where it turns out the universe keeps, proving itself to be far more creative than our theorists. And every time we think we understand planetary formation, a new system is observed that foils our understanding of the universe. So, back to the drawing boards. Now, moving on, I now have a roundup of things gone wrong and things starting to go right. Last week, we heard that the Chandra X-ray Observatory had gone wrong. It hadn't gone super wrong. It turns out that we now understand that the Chandra X-ray Observatory put itself into safe mode after a 3-second glitch in one of its gyroscopes. During that 3-second period, the gyroscope essentially sent data to the onboard computers that made no sense. And the computer went, "No, I don't believe you," in a very computer kind of way. As a result of getting this bad data off of the gyroscope, the spacecraft pointed itself so that it would get the maximum possible amount of sunlight on its solar panels and put itself into a mode where it could communicate with Earth and get everything back on track, going to backup hardware and software as needed. Hardware is needed. Now, after people here on Earth reviewed what had happened, they were able to determine this was a temporary glitch, and Chandra's now out of safe mode and is back to doing the fabulous observations that we rely on as scientists to help us understand what our sky looks like in X-ray light. Now, one of the things that's important to remember is Chandra is 19 years old. It is a result of the amazing Great Observatories program that came out of the 80s and was launched in the 90s and early 2000s. Chandra was only supposed to last 5 years, but it keeps getting extended mission after extended mission and is still rocking the science. So here's to hoping that this little spacecraft that can just keeps on showing that it can for years and years to come. We don't have a replacement planned, and let's hope our great observatories keep showing their mettle. Now, speaking of great observatories, I have a quick update from Hubble. And in this case, the spacecraft is still in safe mode, and they're continuing to work on trying to figure out how to get it back up and observing in the most accurate way possible. So here we have a slightly different story. Back in 2009, the space shuttle, as one of its final missions, went to the Hubble Space Station, the Hubble Space Telescope, which is in a higher orbit than the space shuttle was generally allowed to go to in its final years. And while the astronauts were there, they replaced the Hubble's gyroscopes, giving it 6 new gyroscopes. At this point, it has a set that are on backup, waiting to be spun up and used, and it has the ones that it uses for day-to-day use. Now, one of those gyroscopes had begun to show wear and tear, and it finally, end of life. Gyroscopes do this. When this occurred, the Hubble, as it is supposed to, went into safe mode, and the operators here on Earth went to spin up one of those backup new from 2009 gyroscopes, and that gyroscope said no. It didn't spin up the way it was supposed to. Now, Hubble can be operated on as few as 1 gyroscope. The science missions that it does, things get tweaked, things get done a bit differently. Hubble was designed to work with 3 gyroscopes. They'd rather work with 3 gyroscopes. It's just a much more efficient system if they can do that. So currently, they're still working on getting it up and running. But I do want to say, Hubble is not lost. I've seen a few press things and a few tweets. implying that, oh no, Hubble is a goner. No, Hubble is not a goner. We just need to figure out what is the most efficient way to use this great observatory. In this case, that's even older. It was launched back in 1990. This is a spacecraft that is more than old enough to drink. And continuing our tale of, things that went wrong last week, we have the International Space Station. It is doing fine. ISS is fine. They did have an air leak a little bit back, but they were able to repair that. These are kinds of things they know how to deal with. But filed under things that we're not as good at dealing with. Last week, the Soyuz launch of 2 astronauts to go and swap out the crew did not go as planned. They had a failure of the second stage of the rocket. They had to bring the astronauts back to Earth on a ballistic trajectory. They didn't even make orbit. They went up, they came back down. Luckily, everyone was fine. The landing was in Kazakhstan. They had them picked up just an hour and a half after everything had gone sideways. Now, this did trigger an investigation into why did the Soyuz second stage go wrong. And as always, when these investigations are started, there's concern over just how long will it take for the investigation to go? How long will it be before we decide it is safe again to launch astronauts on our various spacecraft? We have seen this here in the United States happen with our space shuttle program, both after the launch of the Challenger in '86 and after the launch of Columbia in 2003. Now, in this case, it is a particularly hairy situation because the astronauts in the International Space Station are required for safety reasons to always have a way to come back home. Currently, there is a capsule docked at the ISS that they can use to come back whenever they need, but its maneuvering fuel has an expiration date, and it is currently set to expire in January of 2019, which is just a couple of months away. Under standard protocol, if the fuel is about to expire, you bring the astronauts home, which would leave the ISS without a crew on board. And there's a lot of questions on just how long can the ISS remain safe without humans on board to maintain it. And we also don't have fully tested protocols for docking with the ISS in its current configuration without anyone on board. So this has led to oh no, are we at risk of losing the ISS? Now, over the weekend, word that we got back was we are going to be returning to using the Soyuz soon. The way this was phrased seemed a bit ominous. Soon. Can't tell you exactly when, but it will be soon. I will continue to keep an eye on this, and I will continue to bring you updates as I know more. But the one takeaway I have from that soon, and it just amuses me when soon is the answer to something. The one takeaway I have on this is neither the Russians nor the Americans want to lose the ISS. We have a number of things that are ready on the U.S. side to start testing soon. Here we have the Dragon capsule from SpaceX is planning a first human launch in the near future, and we have an investigation of the Soyuz capsules in Russia. And one way or another, I believe that both nations are determined to keep the ISS occupied and keep this peacekeeping mission with a strong side dose of science going into the future. So this is where we're at, and this is all I know. So please go ahead and type in your questions, and I will answer things as I can and be deeply confused about why OBS keeps resizing the chat window. Now, I have managed to open things so that I can't scroll So if folks can please repeat their questions, I'd greatly appreciate it. So I see Fenrig is asking, I've already asked Dr. Matt this, but I'd like your opinion. If neutron star collisions are a major source of heavy elements, could they produce hypothetical island of stability elements heavier than uranium that we don't find on Earth, but could detect in the vicinity of neutron stars? So I'm going to give you a slightly sideways answer on that. Yes, they could produce them. I don't know if we could detect them. So the way we detect elements is by looking to see what are their spectral emission and absorption lines. And I don't know if there would be lines that we'd be able to detect. I simply don't know. So yes to the could potentially create them. No idea as to the could we detect them. Sorry for the entirely vague answer. Other questions that maybe I can answer. And like I said, please just at me in the chat. And I'm in the process of opening Twitch, so I don't know if that will eat the chat in the process. No, it didn't. Okay. So, any other questions? And always let me remind you that the Daily Space comes to you most Mondays through Fridays. We take holidays off, and I regret to say we occasionally run into technological failures. We are here for you to bring you science at 1 p.m. Eastern, 10 a.m. Pacific, 6 p.m. London time. And I will be back tomorrow to bring you the Daily Space. So I see Graham HW is asking, will you ride on the BFR to Australia if flights are available in 10 years, cutting your travel time to 1.5 hours? So I don't think BFR will be necessarily taking you to Australia or taking me to Australia. That's really something more for a suborbital craft to do. I've been looking and tracking what Virgin Galactic is up to with their spacecraft that was originally designed by Scaled Composite. And they're currently planning to simply do a takeoff and landing in the same location. But their space plane looks potentially comfortable to take that ride on. We also have folks over at Blue Origin working on a space plane. My guess is we're looking at one of these suborbital space planes. And yes, I have no qualms with a suborbital flight once it's tested and safe enough. What I do have qualms with is currently with the suborbital flights, what they're looking at is having people wearing spacesuits because it is dangerous. You are getting high up. And last I heard, these are going to be spacesuits that get reused on a pretty much every day or so kind of cycle. And they fully anticipate that most people will have nausea issues. And the idea of a reusable spacesuit that has had biological fluids expelled into it, perhaps with violence and germs, I want to be rich enough to own my own spacesuit. I'm just going to lay it out there. I'm that kind of a germaphobe. So yes, I would love suborbital to Australia, but I want to save up for my own personal spacesuit. Anyways, looking at other questions. Fenrig is asking, do you think it's now more probable that Jupiter-sized planets can form close to their star, or do you believe they are more likely to have moved to lower orbits very quickly? So this is indeed a question of belief, because there are theories in both directions. I don't know whose theories are right. My thinking is the folks that have migration are probably more on the right track, and that you have things spiraling in as they form, but we don't know yet. And so at this point, it's more a matter of whose papers am I more likely to read. I should be reading all of the above, but Time will tell. We need more observations. And if I were to make a bet on who is correct, and that's all I'm doing is making a bet, just like with racehorses, you don't know who's actually going to win. My bet would be on the migration. Yep, more data crunching is definitely needed, Fenring. So do we have any more questions? Because if we don't, I have a team meeting. Actually, I just need to take off. So I will see you all tomorrow. And as always, give us a follow. Follows are free, and be alerted every time we go live. We are sustained by your subscriptions, and every bit helps. This has been The Daily Space, a production of CosmoQuest, brought to you through a collaboration of the Astronomical Society of the Pacific, the Planetary Science Institute, and Youngstown State University. I'll see you tomorrow. Wherever you are in the world, have a fabulous morning, evening, or afternoon. And remember to get outside and look up. Bye-bye.